Let's see how the second law helps us to understand our common experience better, to see how so many total different events really are just examples of energy dispersing or spreading out of the second law. So here are the conceptual examples. Number one is a rock will fall if you lift it up and then let go. So what is the physics behind of that? So a rock has a potential energy localized in it when you lift it up above the ground. The rock is the system. Everything else it encounters is the surroundings. Drop the rock and its PE changes to kinetic energy, pushing air aside as it falls before it hits the ground. Dispersing a tiny bit it hits the ground and causing a little heating of the rock is unchanged. So, the rock disperses to the air the small amount of heat it got from hitting the ground, but the potential energy that your muscles localized in by lifting it up is now totally spread out and dispersed all over in a little air movement and a little heating of the air and ground. So that is the physics behind the rock. Another example is hot frying pans cool down when taken off the stove. So what is the physics and what is the second law of that event? So a hot frying pan, the iron atoms in a hot frying pan, so it is the system in a room, so the room is the surrounding, are vibrating very rapidly, like fast dancing in place. Therefore, considering both the pan and the room, the motional energy in the hot pan is localized. Its motional energy will disperse if it can and is not hindered from spreading out. Less rapidly moving molecules in the cooler air of the room hit the hot pan. So, transfer of some of their energy to the air molecules. So the pan's localized energy thus becomes dispersed, spread out more widely to molecules in the room air. So the system is the pan and the surrounding is the room air. So our last example is an ice cube melts in a warm room. So why is an ice cube melts? So that is because of the second law of thermodynamics. So how can the melting of a little ice cube in a warm room may be 200,000 times bigger than it is be an example of the second law? So how could that possibly be a spreading out of energy? But the second law has to do with energy dispersal, and there's a little spreading out in that 200,000 first part of the total of system plus surroundings. As we learn more quantitatively about entropy, we will easily prove that motional molecular energy is always more dispersed when that energy moves from a warmer surroundings or system to a cooler surroundings. Hotter goes to cooler spontaneously as always. So that's all. Thank you.